Today we'll not only explore the key differences between data lakes and data warehouses, but also examine the various solutions offered by different service providers in this space. Stay with us until the end as we have a special bonus topic that you won't want to miss. If you haven't already subscribed to the channel, now is the perfect time to do so. Don't forget to like and share this video to support our content. Now let's dive into the details. Both data lakes and data warehouses are used for storing and analyzing large volumes of data, but they differ in structure, processing, and use cases. Data lakes are designed to store raw data, that is structured, semi-structured, and unstructured. This makes data lakes more flexible and better suited for exploratory analysis, data discovery, and machine learning, where the data structure of the data is not a limitation but an asset. Whereas data warehouses are databases optimized for analyzing relational data from transactional systems and line of business applications. Data warehouses always require data to be cleaned and structured in a specific schema before it can be used, making them ideal for operational reporting and structured data analysis. Remember, data warehouse for structured data analysis, data lake for structured, semi-structured, and unstructured data storage. Right? Coming to the real world examples, like for example, data lake. A company like Netflix stores vast amounts of raw user interaction data, that's like clicks, watch history, and preferences in an AWS S3 data lake. Later, data scientists analyze this to improve recommendations. Similarly, another example related to data warehouse, a retail company like Walmart processes daily sales transactions and stores structured sales data in Google BigQuery, right? Business analysts then generate reports on sales trends and inventory management. Differences between data lake and data warehouse. You can take the screenshot if you're preparing for any exam or anything. Definition is data lake, as we already discussed, is a vast storage repository for raw, unstructured, semi-structured, and structured data. Whereas data warehouse is primarily a structured storage system optimized for querying and reporting. Coming to data type, data lake stores raw data in its native format, whether structured or semi-structured and unstructured. Whereas data warehouse stores processed and structured data in tables, rows, columns, like that. Okay. Processing wise, data lake schema on read, that is data is stored first and then processed whenever it is needed. Whereas data warehouse schema on write, that is data is processed and structured before storing. Flexibility wise, highly flexible, supports big data analytics, AI and ML as well. Data warehouse is less flexible but optimized for business intelligence and reporting. Performance, slower for querying due to raw data storage, whereas data warehouse is faster for querying because the data is already pre-structured and stored. Cost wise, generally data lakes are cheaper storage but higher processing costs. Data warehouses are more expensive due to structured storage and optimization. So the common tools for data lake are AWS S3, Azure Data Lake, Google Cloud Storage, Hadoop, Databricks, whereas data warehouse, Amazon Redshift, Google BigQuery, Snowflake, Microsoft SQL Server. Many cloud providers offering data lake and data warehouse solutions. Below are some of the major offerings from AWS. It's AWS S3, right? It's a primary data lake service. You can think it of as simple storage service. It's a scalable object storage service used as a data lake foundation. Whereas Microsoft Azure Data Lake Storage, ADLS, it's also a massive scalable and secure data lake service for analytics. Google Cloud Storage is the service. Object storage for structured and unstructured data. IBM Cloud Object Storage is the service provided. It's also a scalable storage solution for AI and big data workloads. Snowflake Data Lake supports semi-structured and unstructured data alongside structured data as well. And Databricks cloud provider has a Databricks Lakehouse. It's a unified platform combining data lake and data warehouse features together. For the data warehouse cloud-based solutions, AWS has Amazon Redshift. This is a fully managed data warehouse with fast querying and analytics. Microsoft Azure has Azure Synapse Analytics, formerly SQL Data Warehouse, it's known as. It's a cloud-based data warehouse for big data processing and analytics, whereas for Google Cloud, it's Google BigQuery. It's a very well-known one. It's a serverless data warehouse for high-speed querying using SQL. IBM DB2 Warehouse, a high-performance analytics engine with machine learning integration. Snowflake has data warehouse, a multi-cloud data warehouse known for its scalability and flexibility. Moving on, the bonus topic I was talking about, it's a hybrid solution where it's called lake house architecture. So actually, some modern solutions blend the flexibility of data lakes with the performance of data warehouses, and these are primarily known as lake house architectures. So examples for these lake house architectures include Databricks Lake House. It's run on AWS, Azure, and GCP. Snowflake supports both structured and semi-structured data, and also Google BigLake combines BigQuery with cloud storage. You can see the lakehouse architecture here in this diagram. It's trying to have the blend of both data lake and data warehouse with relational databases and non-relational databases, machine learning and data warehousing, analytics and big data processing. So it's having both the data lake and data warehouse combined functionalities in a hybrid solution called lakehouse architecture. If you have reached this far, I'm sure you're finding our content useful. Please subscribe to the channel.